Hi, my name's Kenneth Field. I've got something like 25 years experience in teaching, encouraging and persuading people of the value of good cartography. That's the art, science and technology of making maps. In this short 3-hour video, what I'd like to do is share with you some of my thoughts on how to make good maps. Okay, it's not really 3 hours, they wouldn't give me that amount of time. So let's just spend a few moments together exploring something of the value of cartographic design. First of all, I'd like to take a show of hands. How many of you like maps? Yeah, I thought so. Quite a few of you. Keep your hand raised if you use maps in your day-to-day activities. Again, a lot of you. If the blood isn't draining from your arm just yet, how many of you make maps? Yeah, of course. And finally, keep your hand raised if you've got a qualification as a cartographer. Okay, not so many of you. In fact, just 2. You guys can probably skip this video, but for the rest of you, stick around and let's share some thoughts on cartography. So we've established you're likely not a cartographer, but you need to make maps to communicate the results of your work. Getting that message right is vital so you don't ruin the opportunity of communicating your results effectively before anyone's even seen it. Technology gives us the tools to make great maps, and now great web maps, but it's also relatively easy to make poor ones too. We're going to run through my list of some of the top carto fails I see in basic map making to show you what to avoid. First off on my list of carto fails, avoid rainbow colours. Let's take a look at this first map. It's a choropleth map designed to show numerical data in areas. From the map alone, it's impossible to know which country won more Olympic medals. Is purple more than orange? Red more than green? Who knows? Our eyes interpret different colours as different, but not in any quantifiable way, which is the job of a choropleth map. Now look at this second version of exactly the same data. Instead of rainbows, we've picked a single colour and changed its value or lightness. So now we see more and less. Lighter is less, darker is more. And that supports our cognitive processing and makes it easier to see where there is more or less on the map. We're not finished with this map yet though. Number 2 on my list of carto fails are choropleths that map totals. Based on unequal sized areas and unequal populations in those unequal areas, mapping totals is comparing apples to oranges. Each area is visually incomparable with the others. Now look at this version of exactly the same data, which is now mapped as a per capita. Now you can compare apples to apples and where the most medals per capita were won. Normalising data using rates, ratios, percentages or some other comparable measure is fundamental for choropleth mapping. If you want to map totals, use a proportional symbol map. That's the map type designed for totals. Carto fail number 3 is all about projections. Map projections convert the curved surface of the Earth onto a flat paper map or onto screen. All projections distort maps, but learning how to select an appropriate projection, or at least understanding their limits, is a big help to you. Look at this map in WebMacator. It has a grid of circles overprinted on top of it. On a globe, these circles will be equal in size. On WebMacator, they retain their shape but have massively distorted areas. Regardless of the actual size of Oslo and Singapore, Oslo's area is enlarged by the projection by 75%, making visual comparisons meaningless. If you were looking at population density between these cities, or any others of different latitudes, there's no way of modifying what you see by the distortion the projection introduces. So aerial comparisons really require an equal area projection, such as the one used for this map. Shapes get distorted, but areas are maintained in their correct proportions. Knowing how projections distort your map and making a better choice for your map, or at least include disclaimers, is important. WebMacator may be the default for web maps, but as with most defaults, there are ways to change it. Number 4 on my list, fancy 3D maps. The temptation to use 3D tools is sometimes overwhelming. It's impossible to ignore. Let's map our results in 3D with extruding columns. Let's put it on a rotating virtual globe because everybody likes to spin globes. Like on this 3D map. In a perspective view like this, the foreground is massively overemphasized. Extruded columns point in all sorts of directions. It's impossible to measure a single column height, let alone compare heights across the map. Instead, you can use an isometric view that maintains scale across the image, like on this map. It's a special type of projection for 3D viewing. All of the columns are now relatively scaled across the map, so assessing height becomes a much easier task. Making the map interactive so you can rotate it to avoid occlusions also helps. And it's still cool. My sixth Carto fail is transparency overkill. Mashing up your results on top of an online base map is a very common and a very useful workflow, but adding a thematic overlay to a base map can actually introduce an awful lot of visual clutter. This gets worse if you're tempted to show some of your base map through your own map using transparency, like on this map. Great. You just changed your 6-colour choropleth scheme to over 44,000 separate colours, made it a lot harder to differentiate between your choropleth colours. Instead, look at this version of your map. It's just your choropleth. It works just perfectly as it is, so there's no real need for a base map sitting behind it. If you do need to use a base map though, pick a really unobtrusive neutral one, like a light grey map. 7 on my Carto fail hit list is death by pushpin. The ability to put thousands of digital pushpins on a map, and perhaps even colour them using a nice rainbow colour scheme, doesn't really make the ability to read and interpret it easy. Take a look at this map. Nice simple base map, nice symbology, a lot of points. The problem comes if I ask you to describe the pattern made by the dots, and it really is just a messy mass of dots. Be smart with your analysis, and you can perhaps do some cluster or density work or summarise the data into something more meaningful. On this second example, we've summarised the data into equal area hexagons and created a gridded choropleth. It now makes a lot more sense visually. It supports the cognitive process of comparison, and we can see much more of the overall patterns in the data. Analysis combined with sensible cartography supports interpretation. Finally, on this rapid-fire list of Carto fails is overstating the facts, or the temptation to overstate the facts. Your map is only ever as good as the data and the analysis that you put into it, so be very, very careful about overstating the value of that. Consider this map, which shows a proportion of 3 billion tweets mapped so that red equals a tourist and blue equals a local based on words contained within the tweets. It's a cool looking map, no doubt. You want others to like it. You claim it shows incredible new detail of social and demographic patterns like never before. But let's think about the data source a little. It's geotagged tweets. So is that a good data source? Does it support the map that you are trying to show? 67% of all internet users use social media. Only 16% of social media users use Twitter. They're mostly adults, aged between 18 and 29, and male. Only 1% of all tweets are geotagged, and worse, 13% of those generally have very poor coordinates. In short, the data is full of error, bias and uncertainty, and that's before we make the judgment of whether they're a tourist or a local. And look what happens depending on whether we put the tourist or the locals layer on top. It completely changes the message that the map gives us. So as this final map demonstrates, maps lie. All maps can lie. Making a map that doesn't lie is what we're trying to aim for. So this map might be considered data art, but it's not analysis or cartography. Okay, so that's a rapid breeze through some of my top Carto fails that I see, mistakes that are routinely made on thematic maps as the result of people's analysis. There's a lot of resources out there to help us make better maps and to help you become a better map maker and improve the chances of your map showcasing your work more effectively. First, you could check out our map making evaluation checklist, which we've designed in order to get you to think through all of the different components of the map so that you don't miss something blindingly obvious. Also, there's nothing quite like taking inspiration from others and looking at other great maps. It's often difficult, though, to decide what is good or bad or to differentiate what we're looking at if you don't know what you're looking for. We have our very own ArcGIS online galleries designed to help showcase great design and to also give some advice on how to construct maps more effectively. Finally, our friends at the International Cartographic Association have created a curated blog and a list of great classic and contemporary examples of maps to highlight cartography and encourage people to think about design in their own work. Go take a look. There's a lot of beautiful work out there, and we can all draw inspiration from it. In summary, it's okay not to be a cartographer, but your work demands that you know something about cartography to communicate your work effectively. My final top tip is to always go beyond the software defaults. The chances of a default being exactly what you need to make your map is actually pretty low. But the tools exist to make good and well-meaning maps. Thanks for watching. Remember, communicating the results of your analysis is important, as important as the analysis itself. They go hand in hand. Oh, finally, if anyone's still got their hand raised, you can put it down now.